If you're just now tuning in, if this is your first time on Master Monkey thing, I do suggest you check out the profile for more information. We have these geek shows, bits, bots, and beats. This is a weekly 1800 PST, that is GMT -8 for the rest of the world, 6 p.m. PST for you Californians, which is where we're located at. Other days feature lo-fi beats and stuff as you may hear in the background during the show today. Again, I mention is Beat Pete Vinyl Session number 2. You'll find that on YouTube. Today we've got an agenda, which is unusual. Actually pretty organized today. So I hope you guys are looking forward to this. If you've been following the Internet Toybox project, that's what we're going to be talking about today. At least that's on the agenda. It's possible I might get distracted. That happens. Oh, sorry. You know what? I'm missing my. Where's my? The Internet Toybox project. Quick recap from the previous episode. We covered what the Internet Toybox project was, but you will find plenty of information about it at that URL down in the corner, hackaday.io/diemastermonkey. There you'll find all kinds of information about it increasingly, and just posted today this example implementation circuit. This is actually partially what we built on the previous episode, and you can find that show on YouTube, youtube.com/diemastermonkey. This is basically what we built, except not the servo part, just the LED part. So the right-hand part of it that shows the LED, this is actually what we put together last time. So we have here a remote-controlled camera, a remote-controlled viewer camera. We can change its position from the, well, we should be able to, except let's see what's going on with that. It might be on that already. Oh, there we go. Change its position from the chat menu. Hello. That's over there. Generally kind of shy anyways. I didn't need to get my hands. So users in the chat venue can change the position of this camera, this large camera, so-called stage camera, with commands such as stage right or stage mid, which points it over here where we'll be working shortly. And also you can see the Toybox, which is connected right here, and a Raspberry Pi. I wonder what that's doing there. We'll find out later. And stage left, which will do nothing if you type it incorrectly. Again, I typed it incorrectly. What's wrong? I think it's lag. I must have viewers. That's weird. Why do I have viewers? Again, shout outs to all my lurkers. Lurkers power the channel. And apologies for the bit of a scratchy voice. You can still hear a little bit of last week's cold in there, but it's getting better. So, okay, so let's get back to the stage mid position where you can see the circuits at least a little bit. One of the things you'll see here, we'll get servo Spock out of the way. One of the things you can see here is this little lamp. It's just an LED glue gunned into a really cheesy MacGyver assembly, but works for my purposes. So this is a remote controlled stage light, a miniature stage light for your users to control, with commands such as light off will turn the light off, and light on will turn the light on. And you guys are seeing that happen in the chat over on the left, but if you're unfamiliar with Twitch, you might not recognize that. What that is the chat venue for the people viewing the stream. So the commands for controlling these devices are entered into that chat venue itself. And I'm going to go back to that diagram real briefly. And again, this diagram is available on hackaday.io/diemastermonkey. Just a recent post right there. Very simple diagram, nothing special there. Really not much to speak of. Nothing to write home about, as they would say, but I'm going to give you a second to look at it there, and that will give me time to go get my chat.
I'd like to welcome everybody to the 5Ds late night session.
And we're back. Okay, not really. If you're accustomed to reading schematics, that's not much to look at there, so that shouldn't have taken me too long. But really, this is a pretty typical Arduino connection for an LED and a servo. Uh, there's a little what they call charging capacitor, well, smoothing capacitor here, purely for the purposes of smoothing out the signal to the servo. This is pretty common. It's not very unusual. I'm using a 5-volt power rail, as you'll see there, to power that, and then everything else is common ground, as Lou Reed would have said. Again, this diagram is available at hackaday.io/diemastermonkey, and I'm going to drink some coffee. So if you've got an Arduino Uno and a servo or an LED, and you'd like to put your viewers in charge of it, then that's how you do it. Also, sometimes, so I have my mobile phone here, and sometimes when I want to control this stuff, I'll do it from my mobile device, because you can get to the chat venue for Twitch from your mobile device. So that makes that pretty convenient. I can turn lights on and off and such. I don't typically do that. Actually, the plan is to have other people do that, such as audience, or you could maybe pick an audience member and make them your stage director and put them in charge of your lighting and your camera positions, things like that. And additionally, I also have, you'll see the camera just moved. That's because I was playing around a little bit earlier. And I have it set up so that every once in a while it'll randomly move the camera just for the heck of it, which is cool too. So you could have not just a person, but you could have a script or something like that in charge of the camera. Maybe have it randomly moving around during your performance. Some quick background: I put the whole thing together because I'm a solo performer and I have limited cameras, and I'm a finger drummer, so all 10 fingers are busy the whole time, and I wanted to let my viewers have more variety during my show. And so there you go. See things moving around. Yeah, so the diagram, you can see it over there. On the last show, we basically hooked up the lamp, which you saw Johnny Durden playing with. And on this show, we're going to hook up a servo. So that will be this left-hand side of the diagram. And together, those two things show it how to use the Arduino Uno version of the Toybox. What do I mean Arduino Uno version? Well, actually, here's one thing. I said we're going to hook up this servo, and the cameras are controlled by servos. So what's controlling the camera right now? Interesting question. Well, actually, that's the new version of the Internet Toybox, which I haven't yet shared, but we might play with a little bit later. But the current version of the Toybox runs on an Arduino Uno or compatible, so you'll need that and some Java components, which all of this again available at the hackaday.io/diemastermonkey address, and you can find all that stuff there. So servo, let's see on this diagram. In the diagram, what am I hooking it up to? It looks like the signal pin is hooked up to pin 1911, which is one of the Arduino Uno's PWM compatible pins. So that's cool. So that's what I'm going to do. I'm going to pull out, I'll use one of these here jumpers. These jumpers, I'm going to move the camera back just while I do this part. But yeah, so I only have like 2-3 cameras usually during my show, and I'm gonna really interested to see what people would do if they had like a bigger stage or a wider area for people to move the cameras around. All right, so I'm gonna take a couple of jumpers. I'm gonna pull out pin, what did I say? 1911, pin 11 from the Arduino over here. I'm gonna stand up while I do that. Again, in the background, the beats are Beat Pete vinyl session number 2 on YouTube. Beat Pete vinyl session 2, BEATPTE on YouTube. YOUTU. I'm not going to spell that for you. Okay, so got my Got my pin 11 coming out. I got power and ground. Taking off the 5-volt rail here. Oh, okay, so I think what we're going to hook up is I have here a servo, and I'm going to recommend that you not exceed the specifications of the Parallax standard servo, at least for this. Now, I mean, if you are going to, then you should read spec sheets and stuff because it has to do with the amount of current that it is safe to provide directly from the Arduino's power rails. So you're going to want to be careful with that. Now I know this servo is safe. I wouldn't go any higher than this. And once back in the day, yes, I did burn out at one time. Did burn out a what was it? I think it was a micro. I burned out an Arduino micro trying to power a pretty beefy servo. Actually, it was a really stupid mistake. Why am I using this? I don't need this. So I'm wiring up the signal pin from the servo, which is the white lead, although it may differ on yours. But if you're using a Parallax so-called standard servo, then it should be a white lead. Generally, it goes like ground-powered signal. And I'm going off mic for a minute. I need my... And we're back. Again, I want to give props to Beat Pete, Final Session Part 3. That's the background beats tonight. Beat Pete Final Session number 3 on YouTube and elsewhere. So while I was off mic, what you saw me do is make the connections that you see on the left-hand side of this diagram from the servo to pin, where were we going? Took the signal off pin 11. I didn't use a smoothing capacitor. It's not really mandatory. And I'm not 100% sure why Spock is moving already. What is doing that? Very interesting. Oh, you know what? I do know what it is. There's some RGB code running on that pin, now that I think about it, and that's another story. So also there are a couple of different versions of the Internet Toybox. This right here is just my experimenter's kit that I keep handy, and it is also the production kit that I use for my shows. But there's a more advanced incarnation that I am offering to interested stream performers. If you got, I think probably like, yeah, I guess $40 would be okay. $40 for this, and like just compensate me for the shipping for wherever you are too. And you could hook these things up and then have your audience in control of such things, which would be awesome sauces. I'd like to see someone with a really big audience try it out. So I happen to know that there is some RGB code running on that, and that's why it's randomly changing it up. But actually, it's kind of cool. I'm tempted to just leave it on there. So if it were on another pin, it wouldn't be doing this. Any other pin just happens to be that pin. So now that we've done that, we really shouldn't have to do anything. In order to address it, we use at this point, fairly standardized protocol for this. We could say something like, geez, I'm going to say 60. B1P13A60, B1P13A70, we should move it B1P13A10. What is going on with this? Oh, you know what? It's on pin 11. 1P11A70. B1P11A10. There we go. So that's how we move the. Oh, I have to move the camera. Ah, I figured it out. My E key has something stuck under it. I knew something was wrong because I never typo. Okay, so B1P11A 50 will send the servo Spock to the 50 position, and oops, no, B1P11A50 without a bang in front, and B1P11A75 will send servo Spock, which is what we call them, disasters, to the 50 position, and B1P11A75 sends servo Spock to the 75 position. And I'm going to turn off that random thing that moves the camera randomly. So I covered in the previous episode how it is that commands like stage, my E key, stage right and stage left and stage. I gather Johnny Durden likes that that sticker. It's the EFF slogan, or one of their slogans. How that gets translated into a low-level command, and there's a diagram about that at hackaday.io/diemastermonkey. And we covered that in the previous show, but we're going to visit that right now anyways, on account of I'm going to turn off. I'm actually going to turn off the thing that's randomly moving the camera once in a while. It's happening over at MooBot. So I'm using MooBot and Nightbot for this, and it supports any other bot, your bot, whatever bot. And there's a good reason for that, although I'm thinking of adding the support for what the bots do, adding it directly to the system itself anyways. Man, it is great that we no longer have to actually log in for these things. Okay, so over at MooBot, or your bot, whatever bot you're using, you will use its custom command list, or whatever capability there is for that. I'm running out of chat battery power. Okay, so over here you'll find there's a bunch of these commands in here, and that's because I've been using this system for some time. So each of these commands, well, not that one. Let's use the lamp one. That's a better example. So you see lamp off here. When the user types in exclamation a bang lamp off, the bot responds with B1P08D1, which is the command to turn the lamp off. And so that is how, when the user types lamp off, it turns the lamp off. And they type lamp on, and it responds with, guess what? The opposite, B1P08D0. Doesn't matter because you only have to type these in once, these aliases for your commands. Now, the cool part is, so MooBot and different bots have different features, and I won't get into the religious discussions about bots. People become very, very loyal to their bots. So one of the cool things about some of these bots is they can have random timers or user controls. So I could limit it such that only subscribers to my channel would have the capabilities of moving the cameras around. But everybody could, like, say, maybe everybody's allowed to turn the lights on and off, but not everybody's allowed to move the cameras. Or everybody's allowed to move the Spock, but you have to be of a certain level to, move something else or something. So that's why I've done it that way. So actually, we only went there so that I could disable the timer that's randomly moving the cameras just for the heck of it. But it does go further to illustrate. There's actually that whole topic is covered in much more detail in the previous episode of this show, which you can find on youtube.com/diemastermonkey. Okay, so actually, I think that worked out pretty well in only only 30 minutes, and we've already gotten a servo working. It's already set up. We can simply to control it. What was it? It's B1P11A, and then a number generally between. Well, it depends. We can get into that later, but 85 will probably work. See, so and then Spock moves to the 85 position. Depending upon the kind of servo you use, this range will differ, and it will even differ somewhat between individual servos based on their construction and such. So what I like to do, how I come up with these, is now that I've got that set up, I'll go in here and I'm just going to copy it. Now that I've played around with the syntax a little bit and I know how I like it, then I go back to my bot and I'll go to the command list. And you will see that there's already a command in here for this, and that's because this is really all just an academic exercise. These things already work. I'm setting it up for the purposes of this how-to video. Okay, so here, this is again another cool thing that I don't have to do. MooBot already supports providing an argument or accepting an argument from a chat command. In this case, what I'm doing is I'm having MooBot send B1P11A and then whatever the user typed after that. And I'm assigning that to the command called model, right? So this way, once I've saved it, we can go into the chat menu and I'll be able to type model, bang model, and man, I got to fix this E key. Model 18. Right? And it responds with B1P11A18, which moves servo Spock to the 18 position. See, isn't that cool? So this way you get you benefit from all the features that are provided by your chatbot, and you don't have to wait around for me to add these features, and you don't have to complain to me about features that I don't have in the pipeline. You can go complain to Nightbot or MooBot for different things you want, and I can focus on the application, on the system itself. So, which is the right way to do it. So, and special shout out to Leonard Nimoy. We miss you, Spock, and we thank you for everything. Okay, so mission achieved. Wow, award yourself a star. We got a servo connected, and we got the lamp connected on the previous episode, and it's all good to go. So if you followed the past two episodes, and again you can see the previous one on youtube.com/diemastermonkey, then you've already hooked up the right-hand side, so you've got viewers in control of the lamp, and you've just hooked up the left-hand side, minus the smoothing capacitor, which we don't really need, although it is advisable. So I recommend you get one. And actually, this is just meant to keep the voltage in the current in the circuit from fluctuating when a servo might suddenly draw a lot of power. Although I think, don't the nice servos have that circuit in there already anyways? Seems like they should. In any case, you can get by without one, but you shouldn't. So again, this example circuit and other information about the project, including the code that you'll need, is available at hackaday.io/diemastermonkey. Now, I'm going to take a quick break at the half-hour thing there, so it's probably 5 to 10 minute break while you listen to Beat Pete vinyl session number 3. Actually, you know what? I'm going to go back to vinyl session number 2 because that thing was really, really dope. And if we're going to have break music, that's what it should be. And thanks a lot for tuning in. Again, special shout outs to Johnny Durden, one of my few repeat viewers. Also, check out his channel, twitch.tv slash, what is it, Drunk at Durden's? Johnny, please feel free to post a link to your Twitch in the thing. And I'm going to put the chat up so that people can see that. And after a quick break, we're going to come back and I'm going to show you what I've been doing. A quick update on the latest news on the Internet Toybox and where that is going probably. So that'll be some pretty cool stuff. So stay tuned for that. Thanks again for tuning in. Special shout outs to the lurkers and lurkers power the channel and the replay traffic on YouTube. Thanks everyone for tuning in. And back in 5. And we are back. Thanks for that break, viewers. Again, background beats were Beat Pete vinyl session number 2. You find them on YouTube, BEATPETE on YouTube. Really great stuff. Always worth a listen. There's like 60 of them and they're all deadly. So do check those out. Okay, so quick recap. We've just hooked up the left half of the diagram. Oh yeah, do check out Johnny Durden's stream at twitch.tv/Johnny Durden, twitch.tv/Johnny Durden. Always really a blast. I don't think I've ever seen one of those shows that I could tear myself away from. They're really great. They do deliver as promised. So this diagram is now available at hackaday.io/diemastermonkey, a simple reference implementation of the Internet Toybox. Now, before the break, I said that if you had followed this episode and the previous episode, pardon me, that you would now have sorry about that, that you would now have a functioning Internet Toybox, and that's true. However, it's a little less simple than that because there's the entire bridge setup thing, which is a bit convoluted still. And that's really kind of my big task now, is to simplify that whole process. Now, all the components are available at the Hackaday address. They're all on GitHub, and you can get all the stuff there. But setting up the RxTX library in particular is a little difficult. At least I found it to be. So on every platform. Now, I also mentioned that the current camera that's currently being used, stage, like for example, when I do this, move the camera with the stage left or stage right commands, my stupid E key, hello. When I do this, well, we didn't hook this up to the Internet Toybox in the recent 2 project episodes. So how's that being done? Well, it's actually being done with this Raspberry Pi over here. So that's a little preview for the next episode. Probably am moving the project to the Raspberry Pi, and it buys a couple of really big things. Where there are some disadvantages, there's no overvoltage protection, so I have to be a little more cautious about what people can connect to it, things like that. And it's bigger, for one thing, except with the exception of the new Pi Zero, which is incredibly difficult to get, and also is a bit fragile. However, we'll work those things out. At the moment, it's already working great. The best part is it completely removes the need for all the serial library setup, which was a major pain in the butt. So now I can ship the whole device as a single unit, and I can send you a light and a servo controlled camera all as one piece, all ready to go, and you won't have to do any setup or installation or anything like that, just basic configuration. So if you've been wondering where the project's been going the last few days since the last big update, that's where it's been going. Um, Simultaneously, I continue to finish up the instructions for the existing Arduino-based solution. So I'm not sure which one will be the one that gets submitted to the Hackaday, the new Hackaday contest. Yes, I will be entering that as well. Um, as you might have heard, the IQ0 genetic algorithm robots project was in fact one of the winners of the Hackaday Adafruit Pi Zero contest. So I feel it's well positioned. It or one of its brethren projects are well positioned uh, for the next contest, for which has actually I think $100,000 prize or something. Should be really nice. So stay tuned for more information on that. And again, visit the URLs down there for information about this and other projects, and check out the profile for stuff about this and other shows. Thanks for tuning in, everybody. Again, special shout outs to Johnny Durden, our only repeat viewer. And replay traffic. Thanks a lot, you guys. Actually, I get a lot more traffic on replay. Really is where all of it's from. And again, always shout outs to my lurkers. Lurkers power the channel. Stay true, stay low. Monkey out.